Hello. In this video, I'll be teaching you about naming acids. So the first thing is, if you look at the formula, you'll know that something is an acid. It says because its formula begins with an H, a hydrogen. All right, so that's the big clue that something is an acid, is its formula starts with an H. There's a couple exceptions to that, but for the most part, if it starts with an H, it should be an acid. Binary acids, remember binary means two things. All right, so in a binary acid, there is just hydrogen and one other element. So there's a couple exceptions to that, actually. Sometimes there's more than two elements in it, but I'll kind of go through those here. So some examples that we go through, it says you just take the anion, right, and you use that as the root word, and then you make it ic acid. So it goes hydro, some blank ic acid, and I'll go through some examples, but as I said, the common form is just hydro, and then whatever the root of what it's attached to is, and then ic, and then acid. All right, that's the general way that this works. And so, for instance, we've given you a couple examples here. If you've got bromine attached to it, it was bromide. All right, and so we changed that to hydrobromic acid. So we keep the root brom in there. Chloride, all right, becomes hydrochloric acid. And that's how that works. And so I want to go through a couple other examples here with you. So for instance, H2S, we have hydro, all right, and then the root here, the root for sulfur is weird, but it's just sulfur. Hydrosulfuric acid, all right. I can do a couple other ones for you. If we have something like H3N, you might call that hydronitric acid. All right, and then as another example, I'm going to give you one of these exceptions. There's this weird one. It gets named like a binary acid. All right, but it is HCN. All right, so you see there it actually technically has three elements in it. That CN, if you find it on the back of the periodic table, that is cyanide. All right, and so we name this one just like we would name a normal binary acid. This one becomes hydrocyanic acid. So if it ends in an "ide" ending, you take off the "ide" part of it, and you replace it with ic acid, and it's hydro, whatever it is, ic acid. All right, and that's how that works. Okay, for oxyacids, it's a little bit different. What we have here is an acid with a polyatomic. Well, we'll say polyatomic ion, okay, to be clear. Now, what we're talking about here is all the list of polyatomic ions that occur on the back of your periodic table. So there are a bunch of them, and this is the general rule of thumb for how this works. It says if your polyatomic ion ends in an ATE ending 8, you change its ending to ic acid. Or if it ends in ite, you change its ending to us acid. And so we give a couple examples here. HNO3, that NO3 is called nitrate. All right, we take the nitrate and we change it to nitric acid because 8 goes to ic acid. For NO2, that's nitrite, so we take the ITE ending and change it to nitrous acid. All right, for HC2H3O2, that thing there is called acetate. And so we change the ending there, then 8 goes to ic acid, so we call this acetic acid. And that's how that works. It notes here as a bit of an exception with some of these oxyacids, phosphate, rather than becoming phosphoric acid, becomes phosphoric acid. And phosphite, rather than becoming phosphorus acid, becomes phosphorus acid. Sulfate, rather than being sulfic acid, becomes sulfuric acid. And sulfite, rather than being sulfus acid, becomes sulfurous acid. And so those are a couple ones where they change. Now, I won't count it wrong if you get these wrong, but like note the fact that that root word or that stem word changes when we're going from the polyatomic. So that's just for phosphorus and for sulfur. There's a bit of a change there in the way that it's named. But other than that, you can just generally follow the rule of thumb. So we're looking at these acids. I'll probably actually just go through the entire list here. HCl, this is a binary acid, H and just one other thing. So we call it hydro because it's binary. And then that's chlorine, so chloric acid. This next one, hydro, and then because it's binary, and then the root word of iodine is iodic acid. All right, this next one, HBrO3, that is not binary. It's got a polyatomic or an oxyacid structure here, so we don't need hydro. We find out what the BrO3 is. That's bromate, so we call this bromic acid. HClO3, ClO3 is chlorate, all right? So this becomes chloric acid. HF, that's binary, so we call it hydro, and then fluoric acid. H2SO3, SO3 is sulfite. All right, ite goes to us acid, so this is sulfurous acid. H2S, binary, just two elements, so we say hydro, and then this is sulfuric acid. HClO3, funny, this is the same as number 4. That is, oops, no hydro because it's not binary. So this one is just chloric acid. So we go chlorate, ClO3 is chlorate, and that becomes chlorous acid. PO4, PO4 is called phosphate. H3PO4 then is phosphoric acid, because 8 goes to ic acid. All right, now we're going to go the other way. We've got here, it says hydrobromic acid, so we've got to go from the name to the acid. Now, something you might not have noticed up to this point is that there are actually a different number of hydrogens depending on what acid we're talking about. To figure out how many hydrogens, you just look at what the charge is on the anion that it's attached to. And so bromine has a -1 charge on it, all right? And so that means it takes on 1 hydrogen when it's in an acid form. So hydrobromic acid is just HBr. Perchloric acid comes from ClO4 minus, all right? Since that has a -1 charge, it just needs 1 hydrogen. So HClO4. Hydrophosphoric acid, this indicates here that it is a polyatomic, a binary acid because it says hydro, so it's just hydrogen and phosphorus. Phosphorus normally has a 3- charge on it. It's in the same column as nitrogen. And so that means it needs 3 hydrogens on it. So we say H3P. Dichromic acid. Dichromic acid comes from dichromate. Dichromate is Cr2O7. All right, and that Cr2O7 has a 2- charge. All right, that means we need 2 hydrogens on this one. So it becomes H2Cr2O7. Phosphoric acid, that comes from phosphite. Phosphite is PO3 3-. Since it has a 3- charge there, that means it needs 3 hydrogens. Hypochlorous acid. Hypochlorous acid, this is hypo, not hydro, so be careful. Hypochlorous acid comes from hypochlorite. Hypochlorite is just ClO. It's ClO-. If we've got that, then we just need 1 hydrogen, so it's HClO. Hydrochloric acid, that's a binary, hydrogen and chlorine. Cl has a -1 charge, so it just needs 1 hydrogen. And then sulfurous acid. Sulfurous acid comes from sulfite. Sulfite is SO3 2-. That means it needs 2 hydrogens, so we're going to have H2SO3. So that is how you go about naming and writing the formula for acids. As always, look that over. If you have any questions about any of that, make sure that you come in and ask. The biggest thing with acids is to make sure that you know whether it's an oxyacid or a binary acid, and then you have to remember the rules for how you name it in each of those different cases.